I'm Professor Caudill, and we are finishing up with vectors. So we're on 21. What's wrong with the following expression? Magnitude of C equals these two vectors. So um, the book probably says you can't do this, but if one of these is 0 and C is 0, then you could get 0 because 0, I guess, but I don't think that's what the book would probably want you to say. Um, so I'm gonna say you can't do this because C doesn't have a direction, assuming A and B are not 0. All right, so it's A, well, B, C equals AB. So probably similar to A. Just another thing is, what does this mean? They need to be more specific. Like, is it a dot product or cross product? I don't know if it's really a big deal if you omit the dot, but maybe that's not good notation. Um, I think I've done this before where I've left out the dot. I don't see anything wrong with this except for that if you really want to be picky about it, I guess. C equals A cross B. Okay, so if that's the case, then um, C could be uh, C could be, and these questions are just so vague. So yeah, when you take a dot product, I'm going back to A here. When you take a dot product, you get a number. That number could be C. It's not a vector. But if the book's implying that there's a third vector, C might have to be um, might be like the angle of that. Um, yeah, so these questions are very vague. So when you take a cross product, you're going to get a vector. So this is not a vector. Okay. Let's see. So D, um, C equals A, B. What's wrong with this expression? Um, Again, they're pretty vague on what C and A. This question, this 21A, this really bothers me because they don't really specify what C. You might assume it's a magnitude, or you might assume it's just a number. So C equals a constant times B. Um, so what's wrong with this? There's no, it's not, so you don't need to specify the dot product. This is just A times V, which is fine, but C is not a vector. C needs to be this to be true. DE C plus 2A equals B. Similar stuff. No, B needs to be a vector for this to make sense, unless it's a 0 vector, which is 0. So here's the problem, is 0 is the same as a vector with one element. Okay, which is the same as 0, 0, vector with 2 elements. So that's why the book is very vague. So E, F, A cross B. Again, you need to have 2 vectors to do a cross product. G, A dot B equals a vector, which is not a vector. It should be a constant or number. Okay, G, let's scroll up. H, C equals 2, A dot B. Okay, so what's wrong with this? This should be a number. Maybe you could have C equals 2. And also, I don't know what the order of operations is. I'm guessing it's the same. So it's like exponentials. It's like parentheses, exponential, parentheses, exponentials, multiplication, addition. So I think this implies that, but it's not clear. So I C equals A over B. It's possible because you can't divide vectors. I know in linear algebra you could do something like a matrix times the inverse of a matrix, and that might be equal to this. And the order matters, so don't take me on my word, but it might be this instead. But the order does matter where this goes. So, but that's a little more abstract, straight at linear algebra. J C equals A over B. So this is another way of saying B to the negative 1 times A vector, which if A and B negative 1 equals 10 to the negative 1, then what this is saying is C equals 10 to the negative 1 times 2 times. So that should be fine. Okay. 22. Cross product. They vanish. I don't know, like what do you mean vanish? Like, is 0? Um, all right. We're going to get a third opinion. Parallel or anti-parallel? So then it's either like this or what's anti-parallel? I think Anti-parallel is might be like this. Um, okay, I found it. So parallel and anti-parallel. So I was correct. Anti-parallel is when they're going in the opposite directions. Equals when they're the same magnitude and the same direction in parallel. Okay. All right, so 23, the dot product of two vectors vanishes. What can you say about their direction? So if A dot B is 0, I'm pretty sure that means they're orthogonal. 24, the dot product of a vector with the cross product that this vector has within it. What is the dot product of a vector? Oh, okay. Dot product. These questions are worded very strange. What is a dot product of a vector of a, I think this is what it's asking. So A dot AX. So okay. Let's get a second opinion. Okay, so I notated it right. Triple scalar product identity. Okay, so I don't think I knew that. And also they're using different stuff, but it should hold true either way. So A dot A cross B. Triple scalar triple product identity. Okay. Proof, please. Okay, I feel like I've seen this before. Dot product is, okay, so A dot D equals magnitudes of A and D times cosine theta. Now D is equal to the area of the parallelogram formed by B and C. So doing okay. D is equal to the area of the parallelogram formed by B and C. So I'm taking the dot product of two vectors conveniently on the x and y axis. Okay. And it's saying D, magnitude of D is equal to the area of a parallelogram by B and C. Okay, so D, it's saying D is B cross C. So okay, so in that sense, it should be A, B, C, D is would be like this. Okay. So we're trying to do A dot B cross C, which is equal to A dot D, where D equals, okay. So A dot D equals A D cosine theta. So A dot D is cosine theta. So D is equal to the area of the parallelogram formed by B and C. So I'm thinking it's that. It's saying D is the size of this, which I don't have a great tuition of. So I'm not sure if the language model is correct, but we'll keep going. So A dot B cross C equals A times B cross C magnitude. Okay, times cosine theta. Since, okay. Which basically it turns out to be 0. I don't know if that's what I was asking. Okay, so it's not doing what I asked. It just rewrote it. It's annoying. And now it gives me a different identity. Okay. So, kind of struggling on answering that one. Would help if it was worded a little better. So let's move on to 25. Scuba diver makes a slow descent into the depths of the ocean. Scuba diver. Slow descent. Okay. His vertical position with the boat. Okay, so this is time 1. Next second, he might be over here. And the next second, he might be over here. Maybe I should drop him down in a little bit. Maybe I should rewrite this picture. So, okay, so he's going to drop down. Okay, so you see there's like a displacement vector to the boat over time. Okay, so his vertical position changes several times. He makes the first stop 90 meters. Okay. 90 meters from the boat. Okay. I read this wrong. So this is horizontal. This is his horizontal. It should be, I think the first picture should have been more correct. So we have a boat. First he starts here. Dropping down. That's time slice 1. You'll stay directly under the boat. So then next moment he is here. And then next moment he is here. Okay, so D1 equals -9 J meters. Okay. So D2 equals 3 meters up. -12 J, and this should be an a J. 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 Okay. Descending 12 meters. Okay. 9 down, 3 up, 12 down. From there he ascends 4. And then ascends, and then descends 18. Okay, D6, and then he goes up 7. Okay, and then D7, he goes down 24. Assuming the positive direction up to the surface, express his net vertical displacement vector in terms of the unit vector. What is his distance from the boat? Okay, so we're going to take D displacement vector equals the sum of dn vector dn. Okay, so we're going to get all right. So I'm thinking, do I add all the, probably easier to add all the ascends. So we have 11, 14J plus, so J 14. Okay, so now we want the negative J's. 24 plus 18, that's 30. 4 plus 8, that is 42. 54. 63. So I can rewrite this as negative 63J. Okay, D is B. 53 minus 4, 49, negative J. Okay, so his displacement is 49 meters. Okay. '26 tug of war game on one campus. Okay. Here's a knot and the rope. We have 15 and 15. Okay. So what is this? Is it 8 people on this side, 7 people on that side? Or is it 15 on here and 15 here? 15 students. So I'm guessing 15 total. Pulling the rope at both ends. Okay, so I'm gonna guess 7 and 8. 8 people, 7 people, 8 people. Okay. 2 students pull force of 100 newtons each to the right. Okay, so F1 equals 2 times 196, and that is in the I direction, and that's in newtons, plus whatever else. Okay, we have 498 negative I newtons plus 5 62 negative I newtons. And 3 150. 3 150 plus 1 pulling 250. Okay. Assuming the positive direction to the right, net pull. All right, how big is the net pull on the knot? Okay, so the net pull is going to be the sum of this. So it's going to be all right, so we're not checking our answers. So I'm going to do some rounding. So this is going to be 2 times 10 to the 2 3 times 10 to the 2 Okay. It's I. Okay, next we have 4 times 10 to the 2. And we're going to say these are negative values. Guess not. Okay. Minus 5 times 10 to the 2 minus 2 okay, which is -9, -11.5 times 10 to the 2. Okay, so I guess this first, okay. 5 times 10 to the 2, -11 times 10 to the 2. So if these were absolute values, 11.5 times 10 to the 2 is greater than this. So it's going to be this side wins. And the net pull is going to be 11.5 times 10 to the 2 minus 5 times 10 to the 2. It's going to be about 6.5 times 10 to the 2, which is about 650 newtons. Does that make sense? We have 400 plus 250 plus 254 plus 250. So that's about 900. F's doing about 900. Just quick math. F1's doing 4. 950. So yeah, I think we are. I think we're definitely right that F2 is going to win. So we'll call that a success. 27. Suppose you walk 8 meters straight west. So your first move is going to be 8 negative I. And your second move is 25 J meters. Okay, how far are you from your starting point? Okay. All right, so this is going to take some brain power. So we have our XY. So 18 west. 25 J. We want to know this vector. We'll call it big M. Okay, so What do we know? We know the directions. This is 180. $25J is 90. So this has to be 90 degrees, right? So no, 45, I'm sorry. $90 plus 90 is 180. Okay. So we want to find M. So M is a magnitude and a direction. So we could say 90 plus 45. We could say the direction is 135 degrees. Now we need to find the magnitude, which is okay. And I don't feel like using a calculator, so we're going to do 10 to the 1 squared plus 10 to the 1 squared 1/2. So it's going to be 10 to the 2 plus 10 to the 2. Two times 10 to the 2. That's about, yeah, so we'll say square root of that. So let's say it's about, let's say M is about square root of 200. So what's 12 is 144. 12, it might be 13, might be 14, 13 or 14. So does that make sense? 13 or 14? I don't. I know we are really roughing this one. All right, I guess I'll calculate it real quick, just to see how far we're off. 18 squared plus 25. 324. No. 950. Square root of that. 30. So it should be about 30. So 18 squared is 324. So we wrote 100. So the answer is, were we in the right order of magnitude? So we had about 14, which is about 10 to the 1. 30 is also about 10 to the 1. So we were in the right order of magnitude. So I would say that that's good enough. Okay, let's move on. Got 15 minutes, 28. For the vectors given in the following figure, use the graph method to find the resultants. Okay. A plus B. Okay, so a plus b is the same as saying ax I plus a y j plus bx I plus by j. So let's break these down into components, and then we can add the i's. So axi equals the magnitude, which is 10 cosine 30 degrees, ayj equals 10 sine 30 degrees. Bxi is going to be 5 cosine 50 degrees, 53. Byj equals okay, so let's do that. 10 30 degrees. So I'm getting 8, let's say 9. Let's say this is 5. And we're getting 3 and 4. So a plus b equals, so I j 12 I plus 9 j. Okay, so now you might ask, does this make sense? So if we have a 30 degrees and we have b, which is 53 degrees, we're asking, is 12i 9j correct? Is asking for the direction? I don't think so. So one, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we have 9 and we have 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we're saying we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12, 9. Okay, and then our components were 3, 6, 9. 1, 2, 3, 4, 5. Oh, geez. And what else? 3 and 4. 3 and 4. So we're asking if you sum these, you get this one, which I would say looks about right. So the degrees might just be, the angle might just be 23. I don't know. Okay, so how would we calculate this angle here? So we would take the x component, which is 12. You know the, okay, so what is that? So that would be theta equals the inverse tangent of 9 over 12. I know it's not asking for degrees, but just to show that we can do it. Adjacent 12 should be 9, and swap these. $36 degrees. So is that about right? That does look about right. So I think we're making good progress. Okay, 7 minutes left. Let's do 28B, which is C plus B. Okay, so we already know B is 3I plus 4J. Okay, so C is going to be all right, so C is going to be C is here, C is 12, negative 60. So C is going to be 12 cosine negative 60 in the I direction plus 12 sine negative 60 in the J direction. Okay. And negative 60. So 6I minus 10J. Okay. So we're going to add these to B. 9I 9I minus 6J. So without looking, we know the angle of C. Angle of C is going to be theta equals the inverse tangent of -6/9 Okay. 326 degrees. Okay, so you might be wondering what that means. So we take 360 minus 326 equals 30, or 34 degrees. So C is going to be -34 degrees. It's going to have 6, it's going to have 9i and 6j, -6j. So that's our, this is C. Now you can see um, yeah, I wonder if the angle is correct. I mean, it's 60 degrees plus 53 degrees. I was expecting it to be a little bit more on the horizontal line, so we might have an error, but the math seems solid, I would say. So, um, yeah, so next time we'll pick up on C, which is D plus F. So 28. D plus F. So we're going to find the sum of this and the sum of this. And we will use probably the same method that we have been using. So you see my notes kind of just go on. So this is everything written down in this video. It's pretty cool. Um, so yes, AX for I, break it down into components. Then you can sum the components. And then if you want to get the angle, you can take in the inverse tangent, which is TOA, opposite over hypotenuse. I'm sorry, TOA, opposite over adjacent, where the adjacent is the x component, the opposite is y. So it's basically tangent of the y component over the x. So it's 9/12, or 9. Yeah, you get the point. All right, so thank you guys for hanging out. Next time we'll do C, D plus F.